Hi friends, today we are discussing about the Fourier series. So in the Fourier series, we are discussing about the long answer question. Here we have the long answer question, that is expand f of x is equal to x by x, pi by x by 2 whole square. Here our having limits are 0 is less than or is less than x, then x is less than or equal to 2 pi. Means x lies between 0 and 2 pi in our Fourier series. So we are having the Fourier series equation is, let f of x is equal to a naught by 2 plus sigma from infinity to n is equal to 1 a n cos nx plus sigma n is equal to 1 to infinity bn sin nx with our Fourier series. It is the general formula for any Fourier series. So where we are finding, where we were have find the a naught here, a naught, an and bn are our obtained using the Euler's formula. By using Euler's formula, first we are using the a naught formula, that is 1 by pi. Here it is the most important formula for discovering the value of a naught. So a naught is equal to 1 by pi integration 2 to 2 pi f of x into dx is equal to, here all should remember the limits what we are used in the integration. It is from 0 to 2 pi. So 1 by pi to 0 to 2 pi integration, we are having the equation f of x is nothing but pi minus x by 2 whole square. So we are integrating with the respect to x. So here we are taking the 2. 2 is nothing but here 2 square is 4. So 1 by 4 is replaced before the integrations, because of constant. Integration of constant is nothing but a constant while in the denominator. So we take the denominator value constant out of the integration. So it became 1 by pi. Here integrations goes to 0 to 2 pi minus x whole square dx is equal to, here we are having minus, we are taking minus 1 in the left side of the integration and right side of the integration. So left side of integration get cancelled with right side of the integration here. So we get minus 1 by 4 pi integration 0 to 2 pi x pi minus x whole square into minus 1 dx. So we are having the integration part, that is we are using this formula. That formula is nothing but, 1 minute. Here we using the formula, that is f of x n into f dash of x dx is equal to f of x by n plus 1 power of n plus 1. Here we are taking pi minus x is nothing but, we are having minus 1 is the derivative of this form. So the form is in the form of f of x n into f dash of x dx. So it is in the form of this one. So we are taking that. Then we take f of x. F of x is nothing but pi minus x here. Here we taking n is equal to 2. Here n is equal to 2. Means you already know that here n is equal to 2. So n plus 1 is equal to 3, and we are having the denominator also as n plus 1, then it is n plus 1 is 3. So it is a indefinite. So it is a definite integration. So we should substitute the values in the following constants. Sorry, following coordinates. So we are having limits as 2 pi and 0. So we are substituting the values. Here 3 place it to the 4 into 3. So we are having 12. 3 is removed from the multiplication. So here we are putting the value, the limit 2 pi. Pi minus 2 pi whole cube is nothing but pi cube minus 2 pi whole cube is nothing but 8 pi cube. Here 8 goes to, here we are having that 2 pi is nothing but pi minus 2 pi whole cube is nothing but pi minus 2 pi is pi cube. So pi cube by 3, and we are having 0 here. So we substitute 0, then it gives pi. Pi of whole cube is nothing but pi cube. So minus pi cube is nothing but minus of minus of minus is nothing but plus. But here we are adding the plus symbol. So we get minus 2 pi cube by 12 pi. So we are already having here, we already have minus symbol here. So we have minus here and minus also here. So in numerator, we have minus sign, and in denominator, we are having minus sign. So these two get cancelled. So it became plus sign. So that is, and here 2 get cancelled with 12. In which digit? 6 digit. So we are getting the, and here we are also have the pi value. So pi get cancelled with cube, and it gives square. So we get pi square by 6. So our answer is nothing but, our answer is A naught is equal to pi square. A naught is equal to pi square plus 6. Pi square plus 6 is our A naught. So next we are having 3 values in this equation. First we denote the A naught, and next we denote AN, and next we denote BN. So A naught is already we define. So we can define the N naught and we can define the BN. So here AN is nothing but, we are having the formula. AN is the main term for cos terms. In any situation, AN is in the terms of cos n in the Euler's formula. So AN is equal to, here we are having AN is equal to 1 by pi limit, that integration extends to 0 to 2 pi f of x cos nx. Here we are nothing, it is nothing but just we are having the value in A naught. We have a difference in A naught and AN. It is nothing but we are having here 2 pi here. 2 pi here. We are also having 2 pi here, but we have f of x into cos x here. We doesn't have the cos or sin terms here. So we use the trigonometric term in this formula to obtain AN. So for the equation, we are taking the f of x is nothing but, we are already given in the equation that is f of x is pi minus x by 2 whole square. So we are taking the same constant. We are taking these 2 outside the integration. We already done in the A naught. So we get the solution as f of x minus f pi minus x whole square cos nx dx. So here f of x is equal to pi minus x whole square and dx is equal to cos nx. So we are integrating individually the 2 terms. By integrating the individually 2 terms, we get that f dash x is nothing but minus 2x minus pi minus x, and g of x, integration of g of x is nothing but sin nx by n. By integration by parts, it is nothing but we are integrating by parts. By parts, the formula for the integration by parts is nothing but integration of f of g of x. G of x is nothing but integration of f dash of x into integration of g of x. So we are taking derivative of f of x and integration of g of x, and we are both taking the two elements of both integrations. So we get the formula. It is the main formula. This formula is called as biparts. So we are taking an as the formula. By the following formula, we get the equation is 1 by 4 pi into pi minus x whole square sine nx by n, from which limits 2 pi to 0 to 2 pi. So minus, and we are taking minus and integration of 0 to 2 pi minus 2 pi minus x sine nx by n dx. So we are taking double derivative of the following form into next form. So we get that form in, we are substituting the values. So we substituting here 0 get also always 0. So we don't want to move the step. So we take the pi sine n pi n pi by n. So we are taking here, please observe carefully. Here we having the solution in this. It is nothing but the value of this value sine n pi by n is nothing but 0. So 0 minus 0 is nothing but 0. We already know that. And here we are taking the pi minus x sine x by dx. So we are taking two limits. So we substitute 0 element and we also substitute the 2 pi element. So we get the form that is nothing but 1 by 2 n pi integration of 2 pi 0 pi minus x sine n dx. So we are taking the limits and we substitute the limits. So we substitute the limits and we also take the double derivative of the cos nx of n. So we already take here the same process. We also done for this one also. So lastly, we get the solution. We substitute the values. Then we get the solution is 1 by 2 pi of minus 1 by n minus pi minus 1 by n cube pi and sine 2n by pi is minus 0. So we are getting as here minus 2 pi is nothing, minus pi and minus pi is nothing but minus 2 pi. Here we having this form is nothing but it is a 0 element. So the angle of this element is 0. So it is all the term get 0. All the term get 0. So we neglect this element. So we neglect this element. So we get 2 pi by 2 n square pi is minus 0 is equal to, we are cancel the denominator into and numerator into 2, and we are having pi get cancelled in numerator and denominator, and we are having only n square, that is 1 by n square. An is equal to 1 by n square. So we done with the equation. Then we are having, so then we are having that an is equal to some value. That value is nothing but, we are having the value is pi square by 6, and here we are having the an is equal to, an is equal to 1 by n square. So we are having the value is an is equal to 1 by n square. So just okay, we are already done with a naught and an. So we lastly we have the element is bn. So the most important sum in the Fourier series is this sum. So please remember all the formulas you all done in this formula. We have three main formulas. So many of people get confused with an and bn. The sign and cos terms where you place these perfectly all right to do the sum. It is the main important part to take the major step, that is bn is equal to sin x. Someone write bn is equal to cos x. So it is not true. Just memorize the formulas when you are doing the sum. So here we are taking the bn is equal to 1 by pi integration of 2 pi 0 f of x sin nx dx is equal to, we are taking same the formula and the same f of x. There is no change in the following. We take the biparts, we do the integration, then we get the solution that is minus 1 by n pi is nothing but 0 minus 1 by 1 minus 1. 1 minus 1 is nothing but we are having the 0. 0 minus 0 is nothing but 0. 0 into anything is 0. So B of n is equal to 0. So here we having B of n is equal to 0. So we are having A naught is equal to what? Pi square by 6 and B naught is equal to 0 and A naught is equal to 1 by n square. So we having the similar values and we should substitute the following in the given required general equation. What is the general equation we have? F of x is equal to A naught by 2 plus sigma summation of n is equal to 1 to sigma naught, it's infinity A naught cos nx plus sigma infinity to n is equal to 1 bn sin x. So we are taking, we are putting the values, we substituting the values in the following equation. By the substituting of A naught, an and bn in the equation 1, we get the pi by 12 plus 1 by n cos nx plus 0 sin x. We are just neglecting the equation. Then our required Fourier series is nothing but pi square by 12 plus cos x plus 2. Here we are taking from n is equal to 1, n is equal to 2. So we are having the cos 2x by 2 square plus cos x by 3 square. So on, it is our Fourier required Fourier series. It is the most important question in your question paper. It has, so it is very important and it is very easy once refer it. Thank you.